In this video, I'm going to discuss turning of straight threads. Before we begin, we can set in our defaults an option related to threading. Here we have how we define the thread height. You can choose a percentage of the pitch of the thread or part units, meaning an absolute number. I'm going to go ahead and use percentage of pitch. And now we can go ahead and create our profile group. The strategy here is going to be threading. And I'm going to be locating on the outside of the part. So we're going to turn these OD threads here. And we do have a thread relief back here. So for chamfering options, I'm going to say no chamfer because we have this thread relief. And now for our infeeds. The first infeed is the first depth of cut. So I'm going to go ahead and maybe set this to about 10 thousandths. The minimal infeed is the minimum amount depth of cut, which is going to be the cut at the minor of the thread. So here, we'll go ahead and leave that at 5/10. Now when it comes to the depth of cut, PartMaker's default is to use a variable infeed based on the angle of the tool. So we decrease the depth of cut as the tool engages more and more material. The idea behind this is because your tool has an angle on it, the deeper you cut, the more material that's being engaged. So by reducing the cut, we keep the load constant on the tool. In our threading options, you can control this. So right now we're using our variable infeed so that we're taking a constant volume of material off the part. We can also set it to a constant infeed or a variable infeed based on a user-specified number of passes. We can also specify number of spring passes or finish allowances, and PartMaker supports multi-lead threads, so you can set values for multi-leads or variable pitch threads, like a lead variation rate. We'll go ahead and leave those numbers at our default, and go ahead and continue setting the other parameters. Thread height, we've been defined as a percentage of pitch, so you can enter your specified value, or you can let PartMaker put in the average. We do need to specify the actual pitch. So this thread is going to be a single lead, and it's going to be 12 threads per inch. So one lead divided by 12 threads per inch. The angle of the infeed is going to be the entry angle at the front of the thread, so this is normally going to match your threading tool. We specify in the tool data dialog what the angle on the thread tool is, so you can enter that or allow PartMaker to capture it right from your tool's database. The clearance is going to be how much PartMaker clears over top when returning to the front of the part in order to make multiple thread passes. Some 50 thousandths is enough here. And the acceleration distance. The acceleration distance is needed to allow time for the spindle to get up to speed to make the correct pitch. Common value for this is going to be a distance of about 2 pitches. So you can see here the tool will start out in front of a part, and as it's moving in, the spindle will get time to ramp up to the correct speed so that when the tool feeds through, the pitch is correct. So I'm going to go ahead and say we're going to do 1 divided by 12 and then times 2 for 2 pitches. Now we can go ahead and select our tool, and here we have an OD threading tool, and it's a 60-degree angle, so we'll select it, and now our tool is assigned. I'll go ahead and click close, and now we have this threading out group here. Now we can define where our thread start and ends right on the solid model. So I'm going to go ahead and define a profile on the solid, and I will then segment my part, and we can choose where our points are. So I'm going to go ahead and start here. Then I want to come to the back, but I want to come into the thread relief. So I'm going to go ahead and use a horizontal constraint, and then I'm just going to approximate this, so I'm just going to use a screen snap mode so I can just extend this back wherever I see fit. So let's come about here. Now we can go ahead and verify this operation so that we can see the actual threading. And there we have it. Now let's do some ID threading. We'll create another group, threading, this time on the inside of the part. Now you can see here we don't have a thread relief. So I'm going to specify chamfering on exit. I'm going to use the same infeed, about 10 thousandths, and then minimal infeed, 5/10, we'll leave that. Now the pitch on here is going to be the same pitch, so 1 divided by 12. And angle of infeed, again, is going to be 60. And we want an acceleration distance here. So same thing, one pitch, and then we want to double it. So times 2. And you could specify your chamfer length. So if you want to control how much of a chamfer there is at the back, along with specifying the angle of the chamfer. We'll say maybe give it half of a pitch divided by 2. Then we'll go ahead and select an ID threading tool in this case. Click close. And I'm going to change the color of this group. Let's go ahead and make it yellow. And then we'll define where our profile is. Start here and come to the back. And then we can verify this. So there's our threading operation. Now, when it comes to outputting the code, we have a few different options. We'll go ahead and generate our process table, and you'll see our 2 threading groups here. So when we post the code, we can see whether or not we want to output a canned cycle. So I'm going to go ahead and say, let's output a canned cycle for both threading groups. And then we'll go ahead and have a look at the code. So here you can see the canned cycle using standard FANUC G76 output for both groups. We also support G92 and G32. If we wanted to change one of these groups, let's say we untick output profile canned cycle and we generate our NC program. Now you can see we have G32. So this specifies all of the X and Z positions throughout the turning profile. And then finally, we have an option in our user data for using a G92 thread cycle. So here you can see the G92 specifies all of the depths of cut. So you have 3 different ways that you can output code for different level of control.